Hello, ladies and gentlemen. Today we're going to be looking at the physical and chemical properties of matter. So your LEQ is here at the top. It says, what are the physical and chemical properties of matter? So take a second to write that down at the top of your page. Before we get into the properties of matter, I just want to give you a quick reminder that matter is anything that has mass and takes up space. Now let's go ahead and talk about physical properties. So any property of matter that can be observed or measured without changing the identity of the matter. So physical properties can be observed with your senses. So you can touch it, you can smell it, you can taste it, you can see it, you can hear it. Those are all ways to figure out physical properties. These are also things that can be measured with a tool, because putting something on a triple beam balance or measuring something in a graduated cylinder doesn't change the identity of the matter. So let's look at some specific properties. So color is a property of matter that you've been figuring out since you were really little. Is it purple? Is it blue? Is it green? Is it somewhere in between those? Shape, is it round? Is it flat? Is it triangular? Is it some combination of those things? Another one is taste. You definitely should not go around tasting everything in the lab, but there are some things you will be allowed to taste, and taste is a property of matter we can experience with our senses. Density. Take a second and write that down. Density is how tightly matter is packed into a space, and we figure that out by measuring mass, by dividing mass by volume. So that's just how tightly that matter is packed into an area. The next one is state of matter. Is it a solid, is it a liquid, or is it a gas? And those are things that can change, but it's still going to be the same matter. So it's a physical property because we're not changing the identity. It may look different, but the molecules have not changed. Another property of matter that we can experience with our senses is odor. What does it smell like? Again, you should not go around a lab and take a big whiff of everything you see. We're going to use that wafting technique. But odor is a property of matter. Hardness is another property of matter that we typically associate with minerals, but everything has a specific hardness. All right, let's look at some more properties of matter. Malleability. This is mostly associated with metals. Can it be hammered into a really thin sheet? So a good example of something that's very, very malleable is gold. We can actually hammer gold out to be only 1 atom thick, and it's pretty malleable. Melting point. So when it moves from a solid to a liquid, what temperature does it have to be? Boiling point. When it moves from a liquid to a gas, what temperature is that? Luster. Luster's a term you may not be familiar with, but all it means is shine. So something that's really shiny, something that has a lot of luster, we call lustrous. Something that is very dull would not have luster. Conductivity. So how easily heat or electricity moves through an object. These are typically things that are really conductive are going to be metals. Our nonmetals or metalloids are not as conductive. So heat or electricity are things that are conducted. Let's go ahead and move down the page. So let's look at the rest of this. So it says, typically physical properties are things you can detect with your senses. Some physical properties like size, mass, volume, and length depend on the amount of substance present. And those properties of physical properties are called extensive properties. Things that don't depend on the amount of the substance are called intensive properties. Things like color and hardness, odor, those are going to be intensive properties. Now this is sort of a little preview for our physical and chemical change unit. Substances that are not altered chemically but merely changed to another phase or separated or combined are going through a physical change. So when there's alteration but the substance remains the same, that is a physical change. An example would be water to ice, and there's an E in the word ice, or cutting a whole apple into 2 halves. That would be an example of a physical change. All right, so let's look at the back. Let's talk about chemical properties. So a chemical property are properties that are measured and observed only during a chemical reaction. So just walking around looking at things, we are not going to be able to know the chemical properties of a substance. They have to be going through a chemical reaction. Let's look at some of these examples of chemical properties. Flammability. Can it burn? Things like paper are very, very flammable. Things like metals are not so flammable. So flammability is, can it burn? Oxidation state. That's just how things change when exposed to oxygen. Some things don't change at all when they're exposed to oxygen. Some things change a whole lot. So what is the oxidation state of that matter? Another chemical property is toxicity. This is definitely not something we just know walking around looking at things. Toxicity just means, is it poisonous? Another one is reactivity to water. A lot of things, they don't really have a major reaction to water, but some things can be really explosive when exposed to water. Another example is radioactivity, giving off of energy by breaking apart atoms. So if you've ever, watched a movie and it said there was radioactive waste, and I'm sure it was green and glowing and all that kind of stuff, that was because it had high radioactivity. Another thing is the ability to rust. We've all seen, old cars, or maybe it's your old bike that's been sitting around for a long time that has been rusting. That is because of a chemical reaction that is actually taking place within that matter. So let's go and talk a little bit more, and we're almost done. So chemical properties show the potential of matter to go through a chemical change or reaction and can only be observed by changing the identity of the substance. So again, chemical properties aren't something we can just observe with our senses. It's not just something we're going to look at, a table and say, oh, it has these chemical properties. You have to actually put it through chemical reactions in order to know the chemical properties of something. Again, here's a little preview. Chemical change. Substances are altered chemically and display different physical and chemical properties after the change. So two substances interact and form something different. So a chemical change, you start with one or two things and you end up with something different. So an example of that would be water changing into hydrogen peroxide. All right, so ladies and gentlemen, that wraps up those notes. If you would like to color them and make them pretty, you are certainly welcome to do so, but you don't have to. So these are, my chemical properties notes that got made all pretty, physical properties. Woohoo! All right, so ladies and gentlemen, on the bottom of that page, I would like you to write a 2 or more sentence summary about what you have learned about physical and chemical properties. All right, thanks. Bye.